Hi everyone, welcome to our video on definite integrals and u-substitution. So definite integrals are integrals that have the little numbers on the integral symbol, which means that we are finding a net area eventually. But sometimes with our integrals, we need to use u-substitution to evaluate. So in our previous video, they were all nicer integrals, just using kind of the power rule or e to the whatever rule. Okay, if it's a u-sub, if we change the variable, so if we do a change of variable, so that's u-sub, then that means we have to change these values. So this is like an x1 value right there, the a, and this is like an x2 value right there, the b. And so if we change the letter from x into u, then what we have is this is a u value now, and this would be a u value as well, u1, u2, which is a quick change, and we'll show how to do it right here. All right, so let's evaluate these definite integrals. So this does require a u-substitution. Okay, so I've got my u. So just like any u-sub, I'm just going to put it to the side. And it looks like this. And maybe, actually, before we begin, let's go ahead and just rewrite the radical as x squared plus 3x to the 1/2. There we go. And then times 2x plus 3dx. Okay, so that's typically how we would do that. Okay, but my u, either way, is what's under the radical symbol or under the 1/2 power. So we have x squared plus 3x is the u. And just like always, as soon as you find your u, get your du, which would be 2x plus 3. And then dx is always attached. And then with this problem, we've got a real nice scenario. Well, this right here is the du, so it's a perfect substitution. And this right here is the u. Okay, but I'm going to highlight these. So again, these are x values. So I want to rewrite. So let's start to rewrite it. But all I'm going to do is just highlight. Let's leave it blank for now. And let's do our substitution. So that in the blue is u to the 1/2 power. And then everything in the red is du, like that. Okay, however, those numbers I need to adjust. And so to make that adjustment, I'm going to use green here. We use our u equation to find our new u values. Okay, and all we do, so again, this here is like x1, this here is x2. So these are x values. All we'll do is plug those in to our u equation. So we're just going to go, let's just kind of put a line here. I'm going to say u1 is equal to our x value that has x1 with it, so the little 0. So all we're doing is plugging 0 in. So 0 squared plus 3 times 0. So this happens to be the same number. Okay, so u1 is 0, so I'm going to put that right there. And then I want to find u2, u little 2. Okay, so I'm using my blue equation there, but I'm plugging in 1 for this in the blue. So I've got 1 squared plus 3 times 1, and then that gives us 4. Okay, so this should be 4 right there. Okay, so notice that, so if I change the letters, so I changed x's into u's, I need to change those x values into u values. Okay, but now I don't have to go back to x. So that's what's nice about this. Now let's just continue. Let's do the antiderivative. So the antiderivative would be u to the 3/2, but then times the front by the reciprocal of that power. So all I did was add 1 to get the 3/2, multiply by the reciprocal, 2/3. And remember, I don't need plus c with definite integrals, but it is ready for us to go ahead and use 0 and 4. So that's what's nice about definite integrals and u-substitution. I do not have to go back to x's. Once I change it into u, I can stick with u. Okay, and then now it's just plug in like what we did in the previous video. 4 is going to go in. So this becomes 2/3 times 4 to the 3/2. And then again, always minus the second one going in. Ooh, the pin freaked out. Sometimes it does that. Sorry about that. Let's scroll. Where were we? There we are. Okay, so the 0 is going to go in. So minus 2/3, 0 to the 3/2. Okay, and then now it's just order of operations. Okay, so this now becomes, well, 2/3, 4 to the 3/2. Doing it without a calculator. The 2 down below is saying do the square root. So the square root of, so this is the same thing. Let's just put it to the side. this is the same thing. So the 2 in the denominator of this fraction is the square root. The 3 would be the power. But you could do it in any order. It's typically easier to do the square root first. So square root of 4 is 2, and then we would cube it to get 8. Okay, so that's what this becomes. So that is 8. And again, you could verify with a calculator. And then minus, this whole thing is just 0, because 0 to the 3/2 is 0, times 2/3 is still 0. And then now we could just multiply it, and it's our final answer of 16/3. Okay, so that's it. So definite integrals with u-sub is, again, just set it up kind of like you do normally with u-sub, but then use one more part with the u to get those different values. Okay, let's do one other. All right, so on this problem, we need to do a u-sub as well. Let me go ahead, and I'm just going to put a line to block it off. All right, so our u, usually if you have ln involved, that should be the u. And then as soon as you assign your u, check your du. So du would be 1 over t dt, like that. Okay, and so that means it looks, and this you could even rewrite as dt over t if you prefer. Okay, and then that way we could see that we do have the match. If we want to rewrite it, we can first to really see the match. So it is ln of t. And then I'm just going to put this t below the dt. So instead of it, so I'm just rearranging it a little bit. So ln of t I'm putting by itself, and I'm just putting the t under the dt. So that way we can really see the u-sub is ready. So there's our du. So again, we have a perfect sub. That's real nice. And then this is our u. Okay, but I see definite integral, so I'm going to highlight it again. And we're going to set equal. And I'm going to leave it blank except the highlight to let me know, hey, I need to plug something in soon. But let's rewrite it as u and then du, like that. Okay, and then I'm going to use my green again to say, hey, this equation right here can help us find the u1 and the u2 based on our x1 right there and our x2 right there. Or I guess technically it's t in this problem instead of x, so that's t2 and that's t1. But either way, I'm just going to sub those values in for that t in my u equation. So I'm going to plug in ln of the first one, the 1, which does simplify to be just 0. And then let's plug in the second one, so ln of e squared. And then, well, we have a rule for this. ln of e squared would just be 2. So remember, if you have ln of e to a power, it is just the power that's left over. Okay, so we did those, and so those that I circled in green have changed into 0 and 2. Okay, and then now it's ready to go. So the bulk of the work is done, and then now let's just do our antiderivative, which is add 1 to the power, so u squared, but then multiply the fronts by the reciprocal. Remember, no plus c needed on definite integrals. And then now I want to use my vertical bar, 0 and 2, and then we'll plug those in. Okay, so the blue 2 is going in, so I have 1/2 times 2 squared, and then again, always minus the second one. Always minus that one, so minus 1/2 0 squared. Now, 0 pops up a lot, which is nice. If it's not 0, be careful, but on this it is nice because, well, this all just simplifies 1/2 times 4 would be just 2, and then this is just minus 0, so this all simplifies real nice to be just 2. Okay, so that's definite integrals with u-sub. So not much different, I say, than our previous ones that were nicer. Okay, I'm nicer maybe in quotes. These took a little longer with the work. Okay, so sometimes they might look worse than they really are, but use that u-sub and then just make sure to change the numbers. That's the biggest mistake that usually occurs. Make sure to change those x or t values or whatever into u values. And then it's usually pretty nice. Okay, so that's it. If you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.